this next video, let's talk about integrating with the log function, more specifically the natural log. So let's do a quick review really quick. We learned that the derivative of ln of absolute value of x was 1 over x. That's something that we've been doing for months now. And we know that differentiation and integration are inverses, they're opposites. So if the derivative of ln of absolute value of x is 1 over x, then the integral of 1 over x is going to be ln of the absolute value of x. They're opposites. So here, right here, we have our official rule. Now, one other thing I do want to talk about. We know that the derivative of ln of x is 1 over x. And the derivative of ln of absolute value of x is 1 over x. We learned that both of those were the same. However, the integral of 1 over x is only ln of absolute value of x. It is not ln of normal x. And here's why. I can plug negative x values into that. I cannot plug negative x values into that. I can plug negative x values into that. So that's why it's the absolute value one, so that our domain is the same for the input and the answer. Okay, now that we've talked about that, let's do some example problems. So let's start right here with number 11. This one, we're starting easy. Let's take this negative 3 to the outside of the integral. So I have negative 3 integral of 1 over x dx. Well, the integral of 1 over x is ln of absolute value of x. And I need to do plus c because this is an indefinite integral. Anytime we have an indefinite, we do plus c. So, there we go. Okay, in number 12, this one is going to have a little bit of a u substitution with our ln rule. So let's start by making this u. So u equals p squared plus 1. So du is going to be 2p dp. So I can see that I need to add a 2 here, because then that is my du. But if I add a 2 there, I need to add a 1/2 here. So essentially what I'm doing, let's rewrite this integral. So if I write it like this, then you might be able to see it a little better. So because these are multiplying, this is the same thing as this. I just kind of separated the numerator from the denominator. So then that way we can see this is u and this is du. So now I've got 1/2 the integral of 1 over u du. Well, 1 over u is going to be ln of u plus c, because it's an indefinite. And then I plug my u back in, so p squared plus 1 plus c. And I'm done. There we go. Let's try number 13. I'm going to have you start this one, but I will give you a hint. Make tangent your u. And the way I know that is because the derivative of tangent is secant squared. So with that hint, I want you to try this one out on your own. Pause the video, try it out, and then come back and check your answer. Let's check what you got with what I got. This is what I ended up with. If that's not what you got, I would pause the video right now so you can look over my work and figure out where you went wrong. With that, let's move on to example number 14. integrate absolute value of ln of x over x. This one is actually also a u substitution. It's a little bit of a weird one though. You're going to make ln of x your u. And with that hint, I want you to try this one out on your own and then come back and see how you did. Let's see how you did. So u is ln of x, so du is going to be 1 over x dx. So first thing, I'm going to take this fraction and separate it as 1 over x times ln of x. Hopefully we can agree that that and that are the same thing. If I were to multiply this across, I would end up with ln of x over x. Then next, I switched these places, which I can do because they're multiplying. 3 times 2 is the same thing as 2 times 3. So I put the ln of x first and the 1 over x second, so that then we can see this is u, and right there is my du. So I get the integral of u du, which, if I integrate that, that's just a power rule. So I get u squared over 2 plus c. And then I plug my u back in, and there we go. Okay, one last example, example number 15. I will help you out and get you started on this one, and then once again I want you to try it out on your own. This time, that 90% rule of 90% of the time your u is on the inside, this time that's true. So you're going to have u is your 2 minus ln of x, and then try to finish it out from there. So pause and then come back to check your work. See how you did on this last one for this video. So if u is 2 minus ln of x, du is going to be negative 1 over x dx. So I'm going to rearrange this. First, I'm going to split these up as 1 over 2 minus ln of x cubed times 1 over x. So hopefully we can see that. That one times that one. If I multiply it across, these are going to be the same thing. I just kind of separated them. Now, in order to make this look like my du, I've got to add a negative sign in there, and then I add one on the outside to balance it. And then I rewrite it. So this is my u, that's my du. Bring my u cubed up to make it negative. And now I just do my power rule right there. Now I brought this 2 out as a 1/2, and the 2 negatives make it positive. And then I just plugged my u back in to the negative 2 plus c. And there we go. That's some basic ln integral rule stuff. In the last video for today, we're going to use this new ln rule to find the integral of tangent and cotangent.